Video I am going to make a module for the queue. So queue is basically used to prefetch the information, and like before directly going and writing the code in the module, so let me explain like what exactly I am going to do and how exactly I am going to build the queue module. So let's see the screen. So first of all, we should know that queue is nothing but first in first out. That means which it's simple to the queue which we are seeing in our general life activities. For example, if we stand in the uh, theater, like movie ticket centers, so the person who enters first will get first, and the person who enter last will get last. So this is exactly how the queue works, and this is very useful to prefetch the information for the processing unit. Okay, so I am exactly taking a 8 position queue. That means it can store 8 values maximum. Okay, 8 values maximum, and we can define size of each block whatever we want. But for this module I am taking each position, okay, each position size as 8 bits, 8 bits, and we can name this as whole a memory. So our first purpose here is to build a memory, and also uh, we should need pointers. That means, so whenever my first value is entered, for example, initially I store 2, the 2 will enter here, and next if, okay, let's take it from 1. Okay, so for example I stored 1 initially, that means 1 is the first value which is entered into queue. Okay, so we have to make a right pointer here, right? This pointer continuously points to the memory location. So whenever I need to store another value, so my pointer should increase, I mean my pointer value should increase to 2, and whenever I'm storing 3, my pointer value should increase to 3. So 4, 5, 6, 7, 8. For example, if I'm storing 8 here, my pointer, which is the right pointer, okay, right pointer maximum will reach 8. And after that, there is no space. So we cannot store more values. So it remains constant after filling 8 values. So read pointer initial value must be 0, and whenever I'm going to read the value, the first value should read is 1, because this is the first one entered into queue, and the second value should which should be read is this 2 and 3, and the last value to be read is 8. Okay, so let's build a Verilog module for this. So before that, we must know what are the ports. So let's name this as Q. Okay, and this is the module, and so let's figure out what are the essential ports required for this queue. Okay, so if anything required we will add later, but for the purpose just add what are the required elements. One is we need to give data to the queue, so let it be data in. Okay, and whenever we want to read one value, that should be fetched from the queue, that is 8 bits, and that should be data out. All right, and what other things are, clock is required and reset is required, and so we have to check whether our queue is full or empty. If it is full, we cannot read more values, and if it is empty, if it is empty, uh, we cannot read any values. But what happens if you have not checked whether the queue is full or empty? Okay, so whenever the register, we are using your pointers, right? Whenever this pointer exceeds the maximum capacity. For example, here we are, if we use here a 3-bit pointers. So whenever it has exceeded its maximum limit, it again resets to the 0 value. So whenever it resets to 0, all the values which are inside the queue initially, those will be resetted. So we should not make that happen. So for that, whenever the value is full or empty, we have to stop the reading, I mean writing and reading operation. So for that I'm taking two values, full and empty. We know that input is the data in and its size is 8 bits, right? So 7 down to 0 data in. This is one, and next one is we all know that clock is input, reset is input, and write enable and read enable are also inputs. Okay, and next we have to check uh, the output are full or empty. These are based on pointers, right? If pointer has reached the maximum, for example, if right pointer has reached the maximum value, that is 8 positions, we should stop it, stop reading. If read pointer also increases and it reaches the maximum position, that means that there are no other values to read. So in this also we should make empty as high. So these full and empty are entirely depending upon the right pointer and read pointer. So, okay, so these are the output. So output which is exactly depending upon right pointer and read pointer, right? So let's, so obviously this output is written inside the always block. That means it should be mentioned as rich, okay, because it will be on the left hand side inside the always block, and this is exactly a 8-bit data. Okay, 8-bit data. All right, so hope we have mentioned all the ports. Now it's time to, okay, I have missed pointers here. So pointers are neither inputs or nor outputs. It's just as reference which are we are using inside our module. So we can make them as registers. Okay. So uh, actually the register, as there are only eight locations. Okay, we can make this as 2 is to 0. That means exactly 3. So it should count up to 7. 0, 1, 2, 3, 4, 5, 6, 7. But we can even use this as higher, because if we start from counting from 1, so it should count up to 8. If we count from 0, it should count up to 7. Okay, okay, if we count up to 7, 3 bits are okay. But if we are counting from 1, then we should require how many bits? How many bits exactly? 4 bits, because 8 will be 1 0 0 0. So for that purpose I took this as 4 bits. Okay, no problem. uh, Right pointer and read pointer. Okay, we have mentioned pointers, and now it's very important to create the memory. Okay, so how do we create memory? So first, uh, register. Okay, and what is our each memory position size? It is, each position should store 8 bits, right? So 7 down to 0. So let's create this as the value for full. So full is equal to, so whenever our, so at which time our full is high, we have to check that. Okay, and our full is high whenever the right pointer is equal to 8, right? If we count from 1, whenever our this pointer reaches exactly 8. Okay, so this is the condition. When it reaches 8, it means it has been fulled. So full should be high, else 0. So we can use this ternary operator in Verilog. This is synthesizable. Okay, so don't confuse whether okay, ternary is synthesizable or not. So why we are not using any if else statement? Okay, we can use this in a single statement. It is also synthesizable. Okay, so this is our right pointer, and next we have to assign empty. Memory of 0, right? Mem Run the simulation. So initially let's reset. So I'm resetting initially, and I'm giving the clock to that. Okay, so just run it. Sorry. Start 1 2 3. Okay, now let's run the simulation part. So in this I need to reset the value. So let it be raised to high, and also we have to force some clock 0, and then this is 100 nanosecond 50 duty cycle. Okay, so let's run this. So you can see this is in hexadecimal format. So let's convert this into sign decimal. So initially all the values are set to 0, and right pointer is set to 0, and read pointer is set to 0. Okay, now remove the reset, and now just continuously write the values into the queue. So for that, write enable should be high. Okay, now I am forcing a particular constant 1. Okay, so let's see if it is appears or not. So you can see here, you can just see my mouse pointer. The first memory location 1 is 0. So while fetching also, this should be read out first. Now let's force another value. Okay, so you can see it now change it to 1 2. Now again, so it's changed to 1 2 3 now. So now you can see that I have exactly forced 8 values into the queue. Okay. So here read pointer, I mean right pointer also reached to the maximum 8. So now what happens when I still try to write the value in the queue? You can see whenever my queue is full, okay, the full will be 1. So this will become 0, and right enable is 1, but and with 0 is, so this is not, so writing is not going to happen. Okay. So if I, let's force some constant 9 in this and run this, so you can see the value is not changing because the queue has reached its maximum position. So so now the values in the queue are full. Now we need to read them out. So for that, so we need to write enable, we should make them 0. So let's make it 0. Now read enable should be high. Okay, read enable is high. Okay. Now you just check at this output, data out. Here data out is, it is like as it is register, it will be in unknown state. Now let's run this. Okay, for first clock cycle, you can see I'm converting it into signed decimal. So 1 is our output because 1 has entered first. Okay, so this is the values we are getting out of queue. Now second time, run it again. You can see out is again 2, next 3, 4, 5, 6, and last 7, 8. So after 8 you can see our empties also went to high because here read pointer is equal to write pointer, both values are 8. Okay, both pointers are equal when this happens, whenever every value is read out. So now like this is the functionality of queue. Now if I want to again make fetch some values into queue, what I need to do, I need to force the clock again. I mean, I need to make this reset, right? So force constant, make it to high again, make it to high. So okay, and run it. So you can see here again my right pointer is set to 0, read pointer is set to 0, and memory is also set to 0. Now full is to, full also went to 0, and empty is went to high because this is empty. Now there is no value in the queue. So hope you like this video. If you have any queries, you can write down in the comment section. I will definitely try to answer them. Thank you.